Good morning, everyone. Today we are going to see about control system, basics of control system. So in unit 1, we are going to have basic elements of control system, open loop and closed loop system, differential equation, transfer functions, then translation and rotational mechanical system, modeling of electrical system, then block diagram reduction technique, signal flow graph. So first we are going to see about basic elements of control system. So let's see what is system. The system is the number of elements or components are connected in sequence to perform a specific function. So what is a system is we are going to have an input and the system where we are going to have a number of components connected in sequence. We are going to perform any specific function depending upon the applications. So here what is control system is it is a device or set of device that manage commands, directs or regulate the behavior of other devices or a system. So system is nothing but human body is a system. A plant is a system where they are going to perform a specific functions, and the control system externally we are going to manage something. So like traffic light or washing machine. So anything else we are going to command externally that is taken as in the control system. So here next one is we are having linear system. So what is linear system is the superposition principle that the response of system is weighted sum of signals is equal to the corresponding weighted sum of response of system to the each individual input signals. So here we are going for superposition and homogeneity. So here h of ax1 of t plus bx2 of t which is equal to ah x1 of t plus ah x2 of t. So next we are going to see about time invariant. So a system is said to be time invariant if its output characteristics do not change with time. Again, LTI system, that is linear time invariant system, it can be represented by constant coefficient differential equations. So next we are going for basic elements of control system. It is type of control, automatic and manual control, regulation and tracking control, open and closed loop control, continuous and sequence control, on-off and PWM control, then SI, SO and MIMO. It is single input, single output and multiple input and multiple output. So elements of control system, we are having plant, actuator, sensor and controller. So this is a basic block diagram of control system where we are going to have the reference signal, error signal, then control algorithm which is used to control the whatever the system we are going to control externally, then actuator, plant and sensor. So this is the control system where we are going to take the output to feedback to the input signal. That is feedback signal where we are going to have output is feedback to input to get the desired signals. So basics of control system, the plant is a system or process through a particular quantity or condition is controlled. Then control elements, we are going to have or generate a control signal to the plant. Then feedback signal, we are going to get the desired output. So we are going to feedback output to the input signal. Then reference point is an external signal we are going to apply near the summing point. So we are which is used to calculate the exact output or not. The actuator, it's a type of motor that is responsible for moving or controlling the mechanical system. And what is open loop? So the open loop system where we are going to have input and output. So here we are not going to correct anything else automatically, and we are not going to have any feedback here, and the disturbance will not be changed automatically. We have to go for manual system. Advantage, it is too simple and economical, easier to construct and always stable. And drawbacks, it is inaccurate and unreliable. The changes output due to external disturbance are not corrected automatically. And this is a closed loop system where we are going to have an error detector, controller, open loop system. There is a plant and a feedback. So here we are going to correct automatically. And here we have a feedback system to get the desired output. And it has a system that the output has an effect upon the input value. So here the advantage of the system are accurate even in the presence of non-linearity, less affected by the noise than the sensitivity provided by table system. Then drawbacks, complex and costlier system. Feedback may lead to auxiliary response. Then feedback reduces the overall gain of the system. More can lead to design a system. Definition of feedback system, it is a control action in which the output is sampled and a proportional signal is given to input of automatic correction of any changes in the desired output. Then we have two types of feedback, positive and negative. So feedback system, the characteristics of negative feedback, accuracy is in tracking steady state value, rejection of disturbance signals, then low sensitive parameter variation, gain reductions and everything. So positive in to increase the error signal and drives the output to instability. Sometimes it is used in minor loops in order to amplify certain internal signals of the parameters. So a lot of differential equations is used to analyze the mathematical analysis to in the mechanical or electrical system to check for the stability, like mathematical models, input-output relations, and response and output for various input conditions. Then what is transfer function? So transfer function, it is a ratio of Laplace transform of output to the Laplace transform. Then in the for input 0 with initial conditions, that is transfer function is equal to T of s equal to C of s divided by R of s. That the C of s is Laplace transform output with the 0 initial condition and R of s is Laplace transform of with input 0 initial condition. So that is with it is not applicable for the non-linear condition. So with this, we can stop the basic elements of control system.